you would always refer back to the axioms whenever possible. And you specifically have to name which one you have to use. You don't necessarily have to write like the number, like number 4, number 2, whatever, because the order doesn't really matter, it's just the name. So in this case, it would be commutative and distributive. So those are the keywords. As long as you include those, you'd get full marks. Okay, moving on to the second question. Any questions about that before I continue? Okay. Yeah, again, this question, okay, this is a general exam tip that a lot of people seem to skip. Take a look at the marks of the questions. So this one is 2 marks, so it's like a little bit of mark, but this one is 1 mark. And it even gives you a really big hint. It's like very short answer. So a lot of people, when they approach this question and they're showing it to me, they're doing some like long proofs. And it's like, do you really think he's gonna ask that from you if it's just 1 mark? That's really usually not the case, especially if they're 1 mark. It's actually 1 word answers or like 1 phrase answers. In this case, we're just trying to prove that this identity works for this function, and the entire answer is functions or vectors. That's it. That's all you write. Because again, you can prove it, but it's been proven before in the course. You don't need to prove it. If you did need to prove it, it would not be 1 mark. So yeah, if you just wrote functions or vectors, you would get a full mark on this question. Moving on, I want to skip this question because I feel like at this point in time, you guys should be able to do simple multiplication and division between complex numbers. If you cannot, I think it'd be faster for you to learn it by referring to the course notes and going through the example with me. Okay, now this question. Again, this is another general exam tip. A lot of you guys seem to have brute force questions. And this is one of the ones that everyone's trying to brute force. They were trying to just actually substitute this value in for x and just solve it. But you could do that technically, but it's just a very slow method, and it's going to cost you a lot of the time on the exam. And again, if you look at the marks of the question and you think about it, it's kind of unreasonable for him to ask you to do all of that work for just 2 marks. So yeah, if you just simplify this expression, you can factor out a 2 from this part, and then you can also just factor this. Does anyone know how to factor x squared plus 1? Yes. Exactly, yeah. So this would just become and then you factor out the 2 from this part, and it becomes x minus j. There's another example of a question like this in one of the other midterms. And it's like a series of long fractions of complex numbers, and you literally can just cancel out pretty much all of them. I'll show you that later. But yeah, after you do this, all of these cancel out, and you're just left with x plus j plus 2. And then now you suddenly can sub in whatever x is equal to, and the question becomes a lot easier than if you were trying to sub it in from the start. Any questions about that? Wonderful. Question 5. Any inputs? I actually want you guys to try this, because I feel like this on the no one? Wow, you guys really. What did the programming exam do to you? Yes, Alex. They're distributive? Okay. Yes, go on. But what is the relationship between those 3? What is there's a very simple relationship between them, I would say. Exactly. What is the complex conjugate of the other? So we know conjugates can distribute. So I'll show this on paper as well. I'll write it down and I'll show it to you guys after. But as Alex said, you just kind of distribute complex conjugates, and that's how you define the relationship between these. This one, like, you need to think a little intuitively about it.
I can't see your paper.
Yeah, I'll show you in a second. Yeah, so this is where I wrote it. I love my handwriting, it's so bad. Okay. Yeah, so the asterisk is obviously the conjugate sign, and it distributes inside. And the conjugate of the conjugate is just the non-conjugate, so the initial z that you have. And yeah, it would distribute, and then that's how you would define that definition.
never think of that.
I could have actually, but I didn't.
Oh, that's so cute.
Okay, this question. Any inputs for this one? Let's see where you guys are at. No energy? Okay, yes.
No.
No? Okay, but then this one is 2 marks, so you're probably gonna have to give more than just no.
Because if you do it, the real part is positive, so it's on the right hand complex way.
The real part is positive, so it's on the, yeah. So yeah, how would you guys go about factoring this? So like, let's say you wanted to solve for the roots. You can't actually factor it, I guess. Yeah, you would actually just apply the quadratic formula to this, and then you would find out that the result is 2 different complex numbers that have the same real component. And that real component is positive, so it's on the right hand side of the plane. So the transfer function is constant. Any questions about that? Should I show it on paper?
Show it. Show it on paper.
Happy? Okay, moving
No,
on.
I said show it on paper.
Show it on paper?
Yeah.
Aww.
No, it says what is C1?
Wait, are you doing 6? Oh, 7 is so
Okay, so this is your polynomial, and surely we know what the quadratic formula is.
That's why I just.
Oh, you change it like that?
Yes? Feel free to make some sounds if you have questions as I go through. So I know.
Oh yeah.
Really don't know.
Wait, how did you make it?
B, negative B is just 1.4.
Maybe I should do that.
It's like 169.
Okay, you guys should, this is something you should probably be comfortable with. It's a little late now, but you should be able to just do some extensive mental math in your head. So you should know that 1.4 squared is 1.96. That's just something that you should have learned. Yeah, and then you can think about it as like 14 times 14, that's 196. And in terms of decimals, that would turn out to be that 1.4 squared is just 1.96.
Oh, I like that one. This is so quiet.
Yes, and then obviously again, you have to be able to do this mental math because you're not going to have a calculator on your exam. The math is not too difficult. It's just like, I would say, maybe not for this midterm, because it's a little too late, but for the final, probably just practice some simpler arithmetic questions just to kind of get your head in that field. Then, yeah, after you simplify this, 1.4 divided by 2 is 0.7. And this becomes 1.96 minus 4 times 0.65 is 2.6, yeah? Agree? Yes, okay.
You know what I searched?
Wonderful. This is still over 2.
I searched up how to do
And
subtraction.
then 0.7. Okay.
I didn't know, like, I know that I can do, like,
Then the square root of 0.64. Anyone can do that in their head, surely?
but, like, I didn't know.
0.8, yeah.
I really searched, like, organic chemistry.
These are just like mental math things that you should be able to do in your head. Yeah, and then you get 0.8. And obviously there's a j because it's negative, so the negative one still remains in the square root. So then this is your final answer. Well, actually this would become like 0.4. So yeah, these are the roots, but the complex part actually doesn't matter. So after you got the real component, you could have just been done with the question. Because all the question was really asking for was if the real component lies on the right hand or left hand of the complex plane. And remember, this is the complex plane. You have your imaginary here, and then your real axis here. The only part real about this is the 0.7, right? Because the argument b squared minus 4ac is, you know, it's going to be negative. If you kind of look at it or just compute it, you'll find out the argument is negative. And because it's negative, that means that part is imaginary. So the only part you care about is the real part, which is 0.7, and it's positive. And that would lie like somewhere here on this plane. And because it's on the right-hand side, the system is not stable. So the answer would be no. Any questions? Yes? Okay, I'll continue. I feel like no one has any energy anymore. Maybe I shouldn't have done this right after the exam. Okay, this one. I don't think this is too difficult of a question. What do you guys think? Like, thumbs up, thumbs down. Easy or hard? Yeah, it's just some algebra, honestly. It's you just need to know that j squared is equal to -1. Then everything else you can probably solve. Like if you just move this whole factor here to the side, you get 2 times -2.5 is -5, and then you get -5 times c times j squared is equal to 1. J squared is just -1, so you get 5c is equal to 1. And if you simplify that, you get c is equal to 0.2, or 1 over 5. Should I show that as well, or can I just continue? Okay, yeah, I feel like this one is not too difficult. It is just one. Okay, this one is a really hard question, guys. Can I get an answer? Thank you. It's just 3. Yeah, again, if you take into consideration polar representation of complex numbers, when you convert them back, in polar representation you have the absolute value of the vector or the complex number, and then the angle which determines its direction, right? And if this is the formula to bring it back, the absolute value would just be 3 cosine of theta plus 3 sine of theta j. This is the formula to bring it back as rectangular representation, and because they represented it by writing 3 here, you just automatically know that 3 is the absolute value. Any questions about that? Yes. In my exam, I literally just wrote 3 and I got full marks. So yeah, you don't need to show anyone. If it's a 1-mark question, you pretty much never have to show it. Yeah, and for like this one, you could literally just write c is equal to 0.2, and you're done. Okay, this question, this is pretty similar to your application questions. So if you did all the application questions in your assignments, it wouldn't be too difficult. Thumbs up, thumbs down on how bad this one is.
But like, if you because it's your back.
Okay, should I cover it, or are you guys going to skip it? Cover it? Okay. I have a tendency to skip all the questions. Okay, so you have 2 impedance systems, okay? An impedance system is a word I just made up that represents resistors and inductors, or resistors and capacitors together. And the impedance is represented by complex numbers, right? You know that from your assignments. And then if the imaginary component of your complex number is negative, that signifies capacitance, or being a capacitor being present in your circuit. And if the imaginary part is positive, that signifies an inductor. Is everyone clear about that? Yes? Okay, I will continue then. So yeah, in this case, in the 1 minus 3j, you have a 1 ohm resistor, for example, and a capacitor that creates an impedance of -3. Okay? And then that's just represented as 1 minus 3j. And then in the second case, it's 2 ohm resistance with an inductor that has impedance of 4. And I say impedance of 4, I don't say 4 henries or 4 farads, because their impedance is not necessarily equal to their capacitance or their inductance. Okay, and then, yeah. So if you add these together, and that's why because if they're a circuit in series, you can just add them together. So, yeah, some of these is just 3 plus j, correct? This is like with a simplified circuit. this is the impedance that the simplified circuit would have. And what the question is actually asking for, in addition to what is their overall impedance, is can it be replaced with another simpler series of impedance moments. So in this case, you could replace the whole thing with one 3 ohm resistance and a capacitor and inductor. Someone tell me. Why inductor? Yeah. So the imaginary term here is positive 1, so it'll use an inductor. And this is the real component, so it's a 3 ohm capacitor, or 3 ohm resistor, sorry. So yeah, the whole thing can get replaced with 3 ohm resistor and a inductor. With the previous one, there's one inductor, right? Yeah, I'm just gonna write it like that. We're gonna continue. Any questions about that? Yes. In every case, you could replace it. If J was 0, then it'd just be a real circuit, so there'd be no capacitors or inductors. It'd just be one resistor. Yeah, good question. Okay, question 10. This is an intuitive question. If you learn by memorizing or going through the slides, it's going to be hard to do this, even though it's actually fairly easy if you just think about it intuitively. That's the thing with linear algebra. That's what makes it hard for a lot of students when they're doing it the first time. It's because you have to be able to visualize the concepts and think about it intuitively as opposed to reading the slides and memorizing formulas, which a lot of people do for courses. So in this case, yeah, it's a polynomial of degree less than or equal to 2. This is important to remember. And has a property that at 5 different points, its value is the same, which is equal to 2. Okay? And then what polynomial is this? And then in this case, it says justify your answer. This is very unlike Douglas. Usually when he has justification, it's going to be a lot more than 1 mark. In my opinion, because you have to justify it, this question should be worth 2 marks. And this hint is utterly useless. Okay, so you could think about it that way. But the way I would approach this question, so we know the polynomial is degree 3 or lower. Okay, what is the maximum number of roots a polynomial of degree 3 can have? 3, yes. And degree 2? And degree 1, degree 0, no roots, right? Unless it's a axis, like x is equal to 0. But why that matters is because that means that if, for example, a quadratic can only have 2 roots, that means at maximum, a quadratic function can only intercept, or it can only have the same y value twice, no more than twice, right? And I'll draw it out for you. So like if you have a quadratic function here, if you take any single y value, there's only 2 instances of it at most. Sometimes it'll be 0. If y is here, for example, yeah, like this is the x-axis and this is the y-axis. If you take this line here, there's no intercepts. And then if you take any line above that, there's always 2 different points of intercepts, right? And what I'm trying to get at is, for example, if you had a cubic function, the most number of times a cubic function can have the same y value is 3. 3 is the maximum amount of times. Okay, and if you go back to the question here, there's 5 different points that it's saying where it has the intercept, or it has the value of 2. That is just simply not possible if it's a cubic, or a quadratic, or a linear. Actually, not for linear, if it's degree 1. But it can be linear, and that could be true, and there's only one case for that. Does anyone want to tell me what that case is? Yes. Yeah, y is equal to 2. That's the only case where it can happen. And that just means there's a straight horizontal line where every single point is equal to 2. And that's the solution. And you could, the way you would prove this question, you could draw it out. You could refer to the fundamental theorem of algebra, which refers to the number of roots, and kind of relate that to how a function of degree n can only have n different points where they can have the same y value. And that would be your justification. Any questions about that?
Is there any way to think about using that here? Because I don't see it.
Me neither. Maybe, does anyone see any way to use this? And I Nice. I know.
Yes.
Yeah.
I guess just in consider in terms of transformation, what happens to a function if you lower it by 2? Maybe make it in terms of graphical changes. What would change if you reduced everything by 2? I think it's just meant to indicate you towards graphical simulation.
Yeah. Maybe it is just to indicate you towards graphical thinking. Yes. Yeah, I don't really see anything else for it, but yeah, you could do this question completely without the hands. Okay. Another habit you guys should get into, especially for these kinds of questions. Question 11, it's a geometric series. Okay? A lot of the people will just, caveman brain, back to the formula you guys learned. It's like, oh, the sum of the geometric series is just a over 1 minus r, right? You guys know that formula? Yeah. You wouldn't use that in this case. Can someone tell me why? Yes, in the back. It converges, yes. Yes, it diverges. You're right. I messed up my terms too. So the first thing you should do when you get something like this is compute the absolute value of the complex number. If you compute the absolute value of this complex number, you would get 1. Okay? And then if you remember, if a geometric series has an absolute value less than 1, that's when you can use the formula. If it's 1 or greater than 1, then the series diverges, which means there is no solution to the sum. The sum is just infinity. Okay? So when here it says find the value or rectangular representation of the geometric sum, you just say no value because it diverges. Yeah, you would take the absolute value of this, and you would find that it is equal to 1 or greater than 1, and then you just say, okay, like there's no solution. Like it just diverges. Yes. Any other questions about this before I move on? Okay, wonderful. Okay, 3D vector. This is more. Yes, another one of those. Can you visualize all the concepts in your head for it to make sense, or just memorizing everything off the slides? So yeah, if you're memorizing everything on the slides, it's going to be a little bit harder. If you're thinking about it intuitively, it's going to be very easy. So you have a 3D vector that is representing the direction of a drone. Yeah, x is west. Yeah, x is west. Y is north, and z is up. Yeah, those are what the axes mean. And obviously, all the axes are orthogonal. And yeah, what it's asking is this. Yeah, so it's just basically defining redefining x and y and z. So instead of it being north, west, and up, it's going to be down, northeast, and then southeast. And I'm going to draw it on the, I can't draw it on the board, you guys will not see, I'll just write it here. Yeah, so before we had this is our, imagine this is R3. Right? This is your up direction, this is your x direction, and this is your y direction. Y direction. And yeah, obviously all of these are orthogonal to one another. And this is what you have. What the question is trying to ask is, what would happen if we just shift everything? So instead of x being west and y being north, so instead of having this and this, we would have one of the axes in the direction of northeast, and the other in the direction of southeast. So we're just basically redefining the direction of the axis. That's what the question is asking for. That's asking why would we or would we not want to do this? And then obviously the last direction would just go from upwards to downwards. I'm not sure if you guys are familiar with the notation of like a dot and an X. X is going into the page, dot is going out of the page. Yeah. So basically you're just flipping directions, but they are still orthogonal. That's what matters. All the directions are still orthogonal, and you would just have to think about it. Yes? There is no significance. I don't think, but yeah, there's no significance. And yeah, so do you guys think, do you guys think we could use it so we would have x be like northeast, for example, y southeast, and then z down instead of whatever it is right now, or what? See what not? Okay. Any other inputs? Yes, Alan? Any other inputs? No. Well, you guys are so shy today. Yeah, so there's actually nothing stopping you from doing that because they are all orthogonal. As long as they're all orthogonal, you can use whatever directions you want. However, when it comes to practicality, it is not practical. You wouldn't want that because it just makes your life harder. Because now you have to, like, from an engineering standpoint, you wouldn't do that. Right? But from a mathematical standpoint, nothing is stopping you. Yes.
This is how every single one I guess
He might have just misvisualized it because I did the same question and I wrote that answer and it got worse. Yeah, so the answer I wrote, this is the midterm I did. So for question 12, I wrote, it is entirely possible to redefine your axes as northeast, southeast, and down because all of the directions are orthogonal, but from an engineering standpoint, it doesn't make sense because now you're referring to north and east with one of your axes. So in terms of engineering applications, it's just not a good idea, but in terms of is it possible, it's very possible. Yeah, he probably just misvisualized the question. It was like, it's not easy, like sometimes you just call him and he reads the question and he doesn't fully understand it, right? Yeah, maybe he wasn't thinking about this question. Yeah, because this one is very similar, but the answer is different. So in this case, the only thing that changes is we have northeast, down, and then southwest. And the only difference is that northeast and southwest, if you just visualize it, are in the same axes. So now you're losing a dimension, and we're no longer in R3. So you're actually losing information if you do that. So in this case, it's absolutely not practical. You wouldn't. Not only is it not practical, it's just dumb. You wouldn't do it. Any questions about that? Okay, I shall continue. Okay. Yes, this one is about subspaces of vector spaces. How do you guys define a subspace? Yes. Okay, yeah. There's three things you need to prove something is a subspace of a vector space. Or only one of those things you have to disprove to say it's not a part of that. So again, if you're proving, you can just disprove any one of the rules that they have. So in this case, they have three rules for it to be a subspace. There has to be a zero vector, there has to be scalar multiplication, and then vector addition. So if you disprove that any of those, then you've disproved the whole thing. But then to prove it, you have to prove all of them. Does that make sense? Yes. Okay, so in this case, the answer is yes. And because he says justify, so you would have to show your work. Yeah, okay, so a very important part of this question is consider all polynomials. So all polynomials of degree exactly 2. Okay? That means literally anything that you can think of that has a degree 2 works. So 0x squared is still of degree 2. It's just 0x. So that is the 0 vector. So there's a 0 vector included. Okay? There is addition, because you can just have x squared plus x squared, that is equal to 2x squared, and that is also in the all polynomial set, correct? So yeah, the set is still closed under addition, and then scalar multiplication. So like, let's say you multiply like 5x squared by like 20, you get 100x squared. And because it says all polynomials, then 100x squared is also still included in that set of polynomials. So again, it's like a really easy question, but it's like honestly a little too easy to the point where it's challenging. So you just have to kind of show your work. And that would your final answer would be yes, it is a subspace. Yes.
0x squared is not a magnitude of degree 2, it's just 0.
It is considered all
No, the 0x squared is still the degree 2.
because it starts off as x squared. No.
Yeah.
Zero vector is where everything. Okay, this is polynomial x squared every time 0.
It does.
Yeah.
There you go. Bullshit. Wait, maybe.
That's interesting because I did this question and I got it right. So, I think he was the one who marked it. Okay, I think what we can take away from that is as long as you can justify what you're saying, they'll probably give you marks. Yeah, so if I did this question that way, where I said, okay, like 0x squared is degree 2 and it is the 0 vector, so that was what I used to justify it, and I got marks for that. So, yeah, I'm not sure. Maybe he just changed his mind after 2 years, or I would say as long as, wait, this is another general tip in the exams. He'll say it at the start too. You can state your assumptions if you have any questions about what you're being asked. So you start the question by stating your assumptions, and then whatever you're saying, even if it's completely like conspiracy theory blasphemy, as long as you're proving or showing some justification, you'll still get marks. Like, even if it's absolutely batshit easy, like as long as you're somewhat referring to some fundamental concepts and have backing, you're gonna get marks for it. Okay, question 15. How difficult is this for you guys? Thumbs up and thumbs down. Yeah. That one. Okay, so yeah, again, it's just proving it the same way. A subspace has to have a 0 vector, has to be closed under addition, and has to be closed under scalar multiplication. Yeah. Something to consider with this one is that these two vectors are technically like the same if you just take out a -2 from the second vector. So if you factor out a scalar of -2, or you can interpret it as if you multiply this -0.5 to the second vector, it just becomes your first vector. Okay? And what that means is if alpha here was -0.5, or actually if alpha here was 0.5, then the whole thing would become 0. Does that make sense? Yeah, because they're just multiplicative inverses of each other, where one is multiplied by 2. So yeah, because alpha being 0.5 makes the whole thing 0, we prove that there's a 0 vector in the subspace. If you add any, so for example, let's say you had one case where alpha is 3 and one case where alpha is 4. And if you add those two together, you'll still get a case in which can be represented by 1, 2, -3, and -2, -4, and -6 multiplied by alpha. And I'll show that in a second because I realize it's not too easy to visualize. By doing that, you would also show that it is closed under vector addition. I forgot what the question was. So yeah, let's say you had a case where alpha was 1 and a case where alpha was 2, for example.
You have to check if there's a 0 vector. So you can, if you add them,
This one,
it's still like
this one.
true, and it's still the correct vector space. Yeah. If you multiply them,
What your upper would be
it'll still be
is
the correct vector space. That's why you should check.
1, 2, 3, plus 2, 4, 6. And you had another case where alpha was 2. Should also draw the arrows so it makes a little more sense. get these two vectors. So you have these two. These two are both a part of that vector subspace. And let's say you added these together. And what you would get is true.
Bardia.
Yes.
Negative, in the first one, you did -3 plus 6 equals -3.
That makes sense. Thank you. Okay, and then you would get this, and then, so the vector -4, -8, 12 can also just be represented by this. Like if you can actually solve for a, in fact. And yeah, like let's say you have this is equal to 1, 2, 3. If you try to isolate for this term, you get this. And then if alpha is 2.5, this is true. That's why it's closed under vector addition. And then wait, a similar reason is also closed under scalar multiplication. Like you can just take any example where you multiply by scalar, and you would find out that it still provides in the same subspace. That's why it is a subspace and not a subset. Yes.
Like when we're actually provide an example like this using certain values, or can you just say that the combinations of those two vectors are subsets?
Yeah. So yeah, you should actually do that. If you take a look at how much space it's given to you.
What's the subset?
There's not really a lot of space to like do all the work I just did. So you could just give like examples of two vectors and say, by doing this, you can prove that they are closed under vector addition. By doing this scalar multiplication, you can prove that it's closed under scalar multiplication. But you want to show all of it. But if you want to like find out for yourself, it usually gives extra sheets of paper, so you can just try it out on a sheet of paper. And then once you prove it to yourself, then it's easier to condense it down and prove it there. Because remember, it's just 2 marks, right? You don't want to yap too much, and you don't want to write too many proofs. Okay? Usually, a lot of it is just get straight to the point, and then be done with it. Question 16 is 1 mark. Does anyone want to tell me what you would write for this question? Yes.
I said no because if you take the scalar multiple of periodic function that has values below it's not
Pardon?
So say you take like y equals 2 sin x, the highest can be 2, lowest can be -2, but it's like part of sin x is not part of that set of values.
I would say that is incorrect. Yeah, it is. If you like still wrote that and justified it, then you might get like 0.5 marks because like there's at least some reasoning behind your answers. But the correct answer is just yes. Like you literally just write YES and you're done. Yes. I'll explain why. Yeah. Yeah. Exactly. Okay, you can. Yeah. Yeah. Exactly. Yeah, you can add multiple signals together. If you couldn't add multiple signals together, then none of the circuitry in this room would ever work, because it's pretty much what circuitry runs on, as long as you're talking about AC circuits. And yeah, there's always a 0. You just have the 0 sign, which is just a straight line, 0. And there's actually a reason why this question, you could say no to it. I was actually talking with Douglas about this earlier. And technically, if you say that, then you're correct. but it's like a really nitpicky thing where you say, here it says all real value functions of a real variable, so like a single variable. But then here it says all functions, and it doesn't specify how many variables they have. So in the event that you have a multivariable function, then you can say this is not true, and you can say no. But then you just have to know that. And, like, in terms of better wording, you would say are all such functions. But you didn't say that here, you just said all functions. And because of that, you could just disprove it by saying multivariable functions do not fall under this, but you guys have not even learned about multivariable functions, so we would know that. Unless you did in the courses. Any questions about that? No, I think it's pretty solid, yeah. Like a lot of this is just proving subspaces, and honestly it's not too hard. You just have to think a little intuitively, remember the 3 things you have to prove, and move on with life. But then yeah, in this case, remember, it's just 1 mark, so you don't even have to show your work. In this case, it's 2 marks, so they want you to show a little bit of work. Here, if you just say yes, you're done. Here, you have to be like, oh, blah, 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 and then say yes, and then you're done. Yeah. Does someone want to tell me how they would approach this problem? Yes, Alex? Yeah. A great way to start, actually. It's the easiest way to do it, so that's what you should be doing. You would just state an arbitrary vector, v, for example, and you would
Find one.
basically you have to solve for v in the event that the inner product of v and u is equal to 0. And you might be thinking, oh, what do I put in for v? And quite literally, you can put anything you want for like, up to 2 of the inputs. So, for example, I could say use this as like just impose v, for example, like any vector v in R3 where the first 2 values, v1 and v2, are just 1. And then you just solve for the whatever v3 would be to solve the inner product. I'll show that on paper as well.
That's not the zero vector expression. Put zero vector down on trust. That's a good thing. I'm gonna fail to say I'm gonna We're just past this.
Okay, so this is the vector you have, vector u. And I'm just going to magically impose vector v out of nowhere.
Why would you judge my class reality? You're just good at everything.
Okay. You want to prove that the inner product of v and u is equal to 0. And then, yeah, again, you just need to find any case where this works. It doesn't specify how to do it. So what we can do is just say, like, this is just 1, 1, v3.
Sure. I'm down.
And solve for it that way. And this would become negative 1 times 1 is 3 times 1 plus 2 times v3, which is equal to 0. Right, and then negative 1 plus 3. No, that's a case, that's true. Yes? You just solve for v3 and then put it back into the original v, and it becomes 1, 1. And then there's quite a few ways to do this, but pretty much actually infinite answers if you just don't think about simplifying. You just basically impose something and then make sure that the inner product is 0. And yeah, anytime where it's like perpendicular or orthogonal, we should be thinking about inner products. Is that a question? If you just wrote the answer down, if you just wrote one vector that works, I think you might just get 1 mark instead of 2. I think if you just randomly pull the vector and said this is the answer, and then also prove that their inner product is 0, you get 3 marks. Yeah. So yeah, one of the points is like showing their inner product is 0. I guess the other part is having a good answer. This is a proof question. Everyone's favorite.
Oh, is this another
You want to be a scalar
No, no, I can stop this.
multiplication.
I'll stop it.
Okay. So what it's asking for is that this is just perpendicular to V, and you could prove this in multiple ways. You could prove it like graphically. You could prove it by just writing that U can be broken down into the projection component and then the perpendicular component, and then you could also prove it by, I guess, giving an example. So yeah, let's say you had a vector U here and then a vector V. This looks more like a V. So U. Yeah, if you take the projection of U onto V, like this, then you get this vector, right? And then what that means is that you have original vector U, okay, plus the projection is here, projection of U onto V. And you have another point where this is perpendicular. Okay? You just think about vector addition. Quite literally, this projection of U and the perpendicular portion of U are equal to U. So by just drawing this diagram, you have proved yes. And then the question was asking for prove that U minus U minus the projection of U is equal to, it's just like perpendicular or orthogonal. And then you can just refer to this and this diagram, and then you're done. It's quite a simple question actually, as most of the proof questions are. Any questions about that? Okay, question 19. This is the only question you guys had that was worth 3 marks. And it's probably just as easy as the other ones. Yeah, because it's 3 marks, you probably know you have to like write a little bit more.
Why is
But I don't think you need it to actually. It's pretty easy. Does anyone have any inputs on how they want to do this? Yes. Yeah, exactly. So you can factor out A and B if they're under the inner product, and you can do that as seen here. Yeah. So you can go to the properties of inner products for vectors, and pretty much any property under here you're allowed to use, and this includes factoring out the scalars from your inner products. So when it comes to this question, so it's saying if you are orthogonal, I actually don't know how to spell orthogonal. And it just wants you to prove that A, V, or alpha, V, and then theta U are also orthogonal. And again, you see orthogonal with inner products. It's typically a good habit. Then you just prove that, or if they're orthogonal, you know that their inner product is equal to 0. Okay, and then a way to check if once they've been multiplied by a scalar, if their inner product still is equal to 0, is just put them under, and then you can factor out the A and B as was proven in the properties of inner products of vectors. And again, you just refer to those properties. Anything under there you're allowed to use. Anything not under there is total blasphemy. then this just becomes AB multiplied by 0. And then you again have to refer back to the axioms that you have of vectors. Actually, in this case, you refer to the fields because scalars are fields, and you'd say, oh yeah, there's one for 0. Where's the one for 0? Field is closed. One of these was for the 0 vector. But yeah, basically you just refer to that one and be like, okay, well, scalar multiplication by 0 gives you 0. And then that's how you finish it. I don't know, find it actually.
Oh, yeah, you can listen.
Well, I think it's just my phone.
I guess you actually wouldn't say that. You just say 0 times AB is equal to 0. Surely you don't lose mark for saying 0 times something is 0. Yeah, that's how you finish that one. Honestly, if you see this, free few marks. So again, general test taking habits, just a summary of everything I've said. If you see a long spiel of algebra, try to simplify it, don't muscle through it. Usually you just always want to simplify first, try to see if you can simplify first to save time. If you see a question is worth 1 mark and it doesn't ask for justification, don't spend 2 hours on it, just yes or no, write 1 word answers, move on with your life. If there's 2, you want to kind of write a little bit more. Your effort should be proportional to the number of marks. And then, like for example, I'll bring up another example. Can I get the point across? Yeah, like for example, this question. It's a very long question. If you try to do it just by muscle, right? Then you say like 2 minus 3j here, 2 minus 3j here, 4 plus j here, 4 plus j here. Those cancel out. See, negative 5 plus j here, and 5 minus j. These also cancel out because you can factor out a negative 1 from this. Or 6 minus 2j, 3 minus j. You cancel these out because you can factor in 2 here, right? Basically the point is, with long questions, you want to try to break them down first, so you don't spend 3 hours doing 1 question that's worth 2 marks. And yeah, honestly, a good habit to have is before you even start the first question, take a look at the length of the exam. You want to pace yourself. Take a look at the length of the exam, take a look at how many marks everything is worth, and where the marks are. Typically, you want to start with the higher mark questions. And if you have an idea how long the exam is, like for example, if the exam is worth 25 marks, and you have 2 hours, it's like 2 marks, 20 marks in 2 hours. Like ideally, you want to dedicate 10 marks per hour, right? So that's like 1 question every 6 minutes, or 1 mark every 6 minutes. So you want to try to divide up your time that way, if you can. And once you do that, you'll have a better sense of time. So for example, for your calculus exam, if you started with like going through the entire page and like figuring out where all the questions are, how many marks they're worth, it'll cost you like 2 or 3 minutes, which is not ideal. But once you have that sense of how long it is and how many marks everything is worth, you can pace yourself better. So then you'll find out, okay, well this question is not working out for me. The amount of time I have to spend is not proportional to the outcome. For example, if it's a 2-mark question and you're like 50-50 on it, you don't want to be spending like 20 minutes on that, right? You want to move on to the next question where you can spend less time and get more bang for your buck, basically, right? So that's the general advice I would have for you guys. And I think, honestly, all of you guys are really dead right now, and I'm really dead because we had an exam. I've been awake since 6 a.m. So I will end it here. If you guys want more help with linear algebra, you can come tomorrow morning. I'll try to get to work at 8:30. And to be safe, okay? Any last questions I can help you out with? Yeah, just remember the general advice I gave you. The general advice will take you a long way. You're gonna pass linear algebra. For any exam, it's always really helpful. And yeah, chem tomorrow, same time, would probably be better. Yeah, I thank you guys. Bye.